All right, today I'm going to talk to you about the semantic web. I'm going to be more focused on a conceptual understanding of what the semantic web is and what it can do for us, and I'm going to tend to avoid the technical details. I dipped my feet into that a little bit as I was researching this presentation, and it kind of goes way beyond what I'm capable of doing here. So to start talking about the semantic web, we're going to talk about Tim Berners-Lee, who has the impressive title of inventor of the World Wide Web. Back in the 80s, Berners-Lee wanted to be able to access other documents on other people's computers on his own computer without having to constantly be switching between different kinds of hardware and different kinds of software. To that end, he essentially created the World Wide Web. He wrote HTML to allow his documents and other documents to be linked to each other. He created URLs, giving a unique location for each document so that the machine could go out and locate the document you were looking for. And he created HTTP, which are the rules that allow documents to be linked together and moved around on the internet. Having invented the World Wide Web, eventually Berners-Lee came up with the idea of the semantic web to truly unlock the potential of the web and all the resources out there. He had the idea that we could link data together and link the relationships between data so that machines could understand what data meant, as well as just humans looking at documents. He wanted to create a web of data rather than a web of documents, and he wanted machines to understand the meaning of the data that they were using. Berners-Lee had three rules that he came up with to create a semantic web out of the web that we currently have. His first rule was that everything has a URI. That's everything, every concept, every idea, every person, every place, every object. Anything that we're talking about on the internet would have its own URI, a uniform resource identifier that was unique to it. The second rule was that accessing a URI on the internet would always retrieve some useful information. When you put the URI into whatever software you were using, you should get back something that was relevant to what you were looking for. And then the third rule was that information would include explicit relationships to other things with URIs. That idea that everything on the internet would have a relationship to other things is the basic concept of linked data, and that's what makes the semantic web possible. It defines the relationships between data. Any unique item that you have on the internet is going to be related to many other items on the internet, who in turn are going to be related to many other items on the internet. And what this does is it enables accessibility and integrations of different data sets on the web. It allows us to essentially take one item and the relationship it has to another item and use that to create a infinite web of relationships with all the different data sets that are out there. And it uses a standard format for data and relationships that will allow computers to use the data from different data sets, different databases, and connect them in meaningful ways. And this is what they called the linked data triples that we've talked about. A linked data triple basically comes down to subject and its relationship to the object. So in the diagram here, we have our subject, we have our object, and we have the relationship between them, and that is a linked data triple. For example, Edgar Allan Poe is the subject. Is the author of would be the relationship, and the raven would be the object in this particular linked data triple. And then we can see how this begins to spread out. Edgar Allan Poe is the author of The Raven. That's one linked data triple. Edgar Allan Poe was born on the date January 19th of 1809. That would be another linked data triple. And we can carry on that on further, because objects in a linked data triple can then become subjects of another linked data triple. So The Raven was published on the date 1845. One of the things that makes the semantic web so exciting is the ability for machines to make inferences, to allow them to integrate new data. Using the linked data triples, that standardized format, new relationships between data can be created automatically by the software, so that we don't have to do that work anymore. It allows computers to analyze the content of new data and make those connections and put them together with the data that we already have. It also allows computers to discover potential inconsistencies when they find that the linked data triples don't match up. An example of the inference, if we look at the linked data triple, Flipper is of the species dolphin, and another linked data triple using the same subject, Flipper, is of the class mammal. A computer can use inferences to create a new linked data triple. Dolphins are of the class mammal. Vocabularies. Vocabularies is how the machines will learn to define concepts and the relationships between concepts. As I was looking, they talk about vocabularies and ontologies, and the two terms are sometimes used interchangeably. Sometimes a vocabulary might be more of a simple set of rules, whereas ontologies is a more complex set of classes and subclasses. But for all intents and purposes, we can consider them to be essentially the same thing, or to serve the same function. And these are the basic building blocks for making inferences. These are the simple rules that the computers use to make inferences and make new connections between data triples. They help to resolve ambiguity between different data sets. They help us to define new relationships, and they help the machines to organize that knowledge so that we can use it. An example of a vocabulary rule. Here we have two databases. Both have a subject, Umberto Eco, and one has the linked data triple. Umberto Eco is the author of Foucault's Pendulum. The other one has Umberto Eco as the creator of Foucault's Pendulum. So the rule in this case might become author and creator are synonyms, and so if we have Umberto Eco as the author of Foucault's Pendulum or Umberto Eco as the creator of Foucault's Pendulum, we're describing the same relationship in that merged database. In another example, we might have a data triple with Umberto Eco as the author of Foucault's Pendulum, and in another database, Eco, Umberto as the author of Foucault's Pendulum. Using the vocabulary or ontology that the computer is using to integrate data, we might decide that Umberto Eco is the same person as Eco, Umberto. So what is the semantic web good for? It allows machines to assemble data from many different authoritative sources into one place so that we can access all of it. The standardized data collections using those linked data triples is going to improve access and collaboration so that different databases in different places in what were originally different formats will be merged together, and all that information will be connected so that we can follow those connections and discover more. It allows computers to understand the meaning of the data instead of just working with numbers and words that the computer doesn't necessarily understand. The computer is going to be able to do some of that work for us. It's going to be able to take that data and put it together in meaningful ways and follow meaningful paths for us and meaningful relationships so that we can then work that much quicker and that much faster. So some interesting resources if you want to learn more about the semantic web. Tim Berners-Lee did a TED Talk where he discussed how he came up with the idea for the World Wide Web and then went on to come up with the idea for the semantic web and what he thinks that will do to technology into the world. OCLC's Linked Data for Libraries video does a really good job of talking about the progression from Web 1.0 to 2.0 and then to 3.0 and how that is particularly important for libraries, the potential there. And then there's a nice documentary called Web 3.0 that just kind of explores all these ideas, the potential of the semantic web, and also some criticisms, some possible downsides or possible roadblocks. Some web pages that you might be interested in taking a look at to get an idea of what linked data looks like. DBpedia is a project where they're taking Wikipedia and turning that into the linked data format. And connecting it to databases all over the world. OCLC WorldCat, their entries have linked data sections in them, so you can look and see how some of that bibliographic data, metadata, translates into linked data triples and then connects around the world. Schema.org is a group that's working on building schema, vocabulary, ontologies, defining those relationships in a standardized way to allow for linked data to be put onto the internet. And then BBC Nature is just an example of a website where they use linked data so that when new and interesting news comes up on any given topic, it automatically, without the intervention of a human being who has to go in there and add the links in, it automatically gets updated and automatically gets connected to other sources of that use linked data around the world. And that's that. I hope that you have a better understanding of what the semantic web is and what it does than you did before we started.